Recording. I didn't have this one recorded. 9.2, more exponential functions. So here is our notes, examples. Let's go through this and let's get in and let's put y for x squared. So y equals 4x squared. And I'm going to hit, I think I'm going to hit second in table because that's probably the fastest way to get to my table. And it starts at -2, so it says it's -2, and how in the heck did she get that?
What? You said squared. Yeah.
What? Oh, it's 4x. No wonder. My goodness. Oh, Lord have mercy. All right. 4, let's hit clear. 4 to the power of x. I'm so sorry. Second table. Alright, so -2 is 0.0625. What? What? Oh, yeah, we could. That's an 8th grade thing. But that's fine. You could do that. You could put it on mode 2. That's probably easiest, all right? Then -1 is 0.250 is 1, 1 is 4, and 2 is 16. So then we're going to graph it. Okay, so let's see here. We're doing, I'm going to start at 2 and 16. I know this is 10, right? Or is it 12? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I was to go up here, this would be about, and if you have a point that's off the graph, it's always wise to go ahead and name it. Okay? I've got 1 and 1, 2, 3, 4. And then I've got 0 and 1. And I've got 0.25. And then I've got 0.06. So you kind of get the gist of this. It's going like this, and it's going up, and it's going to go, okay? You know what that sound is? Like boom, you know, explosion. It's going to go exploding. Okay? All right, so we're exploring the differences that everything makes to this, all right? So here we've got our one graph. Don't you like that straight line I did? That line was looking ugly, wasn't it? All right, anyways, there it is. Okay, what? Oh, well, you know, I'm just not that artistically talented. Okay? So now I'm going to go back, and I am going to go to y equals, and I'm going to put 4 to the power of x, and then I'm going to arrow over, and I'm going to put subtract 8. And I'm going to hit second in table. And now, ooh, look at that. I've got -7.94. -7.94. I've got -7.75. -7. -4. And I've got 2 and 8, don't I? So, plot that one. Let's see. I'm going to start out over here in the positives because it's just so much prettier. 1, 2, 3, 4, 5, 6, 7, 8. And then I have 1 and -4. 1, 2, 3, 4. And then I have 0 and -7. 5, 6, 7. And then this is where I get into 7.75, and then just right there. And let's see if I can make this one look better. Probably not. It's too long of a line for me. And it's going to go down here. What do you notice that's different about the two graphs? What is it lower by? 8, yeah. It's lower by 8. So that's what this is doing right here, isn't it? It's moving. It's, what did we call that? A trans what? When you slide something down, what is that called? Translation. So this is translating your exponential function down by 8. Isn't that interesting? So that's what we want to say. It is, because how is the graph different from y equals 4x in example 1? It is 8 units below y equals 4 to the power of x. So it's been translated 8 units down, sorry. Okay? So let's see what happens now. Anybody have a prediction? No predictions? Oh, well, then I guess we'll find out. Y is equal to... Now, where is that negative sign? It's back with my x, isn't it? Minus 1. All right. So you predict it's going to go back up, but what's going to be different with that exponent being x minus 1?
Oh, it's going to go, from left to right, it's going to go down. Right?
Nope.
It's going to go,
Nope.
It's going to go to right. It's left.
Nope. Look at what happens. Negative 2 is 0.016, okay, or 0.02 is, I guess, what we would round that off to, wouldn't we, if we have our calculator set on mode 2. Then we've got 0.06. Then we have 0.25. 1 is 1, and 2 is 4. And the easiest place to see these differences is when you have whole numbers. And if you notice, what's happened here compared to here, what has happened down here?
All the numbers went down. Because 0.25 was at 1, now it's at 0, and then 4 was at...
It got shifted, right?
It got shifted right how many?
1.
1. So we've got 1, we've got 2 and 4. 1, 2, 3, 4. Here we had 2 and 16, didn't we? Okay. Then we've got 1 and 1, which we didn't have before. And then we have 0 and 0.25. So it's getting shifted to the right by 1. Oh, so it's translating it to the right by 1, isn't it? Then we've got this number, and I know it gets harder and harder, but we're just going to skid that line right there, that x-axis, and we've got this. So it is 1 unit to the right of y equals 4 to the power of x. Okay. All right, let's flip the page. Ooh, getting more interesting.
Why are you doing all this?
Okay, so that was a negative. So what's going to happen when you have a plus in your exponent?
It's going to get shifted to the left.
It's going to shift it to the left by how many?
2.
And then what about this? Where's this going to shift it? The y-intercept is going to be shifted what? Well, it's not the y-intercept. It's just going to shift the whole exponential function up 3. Okay? Because the y-intercept here was at 1, right? And the y-intercept here, we will see where it's at. Okay? So, we're going to go to y equals... What? No.
I measure what?
All right.
Oh, what?
We've got 4 to the power of x, and we're going to stay up there, plus 2. We're going to get out of exponent land and do plus 3. And so this time, second in table, we've got, ooh, look at that. We're going to go to -4. They wanted us to go to -4, which is 3.06. Then we have 3.25, 4, 7, 19, because look at where your y-intercept is, at 19. Okay? So it shifted it to the left 3. No, it went 3 above. I'm sorry. It just shifted it 3 above, and it is 2 to the left. So here we go. -4 and 3. -4. 1, 2, 3, 4, and -3 and +3. 1, 2, 3, just a little above it. And then we've got here, and then we're at 4, and then we're at 7, 4, 5, 6, 7, and then we would be way up here at 0 and 19. So it would look more like this, wouldn't it? Okay? So what happens? It is 2 units to the left or right? Left. And 3 units above y equals 4x. Okay? So, remember that the only time it's going to go this way is when your a value is between 0 and 1. Okay? Alright, it's not going to go that way unless your a value is between 0 and 1. Okay, let's look at this. This is not saying that it's going to start at -4. Okay, remember, this is translating it. So, and one thing we probably should have done is we should have left probably 4 to the power of x in here so that we can compare the graphs. Okay, so then we have -4 to the power of x. We'll put the table, let's just look at the graphs and see what's the difference. So there's blue, that's 4x. There's -4x. So all it's done is what? It's flipped it. It's reflected it. That's correct. And remember quadratics, when you had that out there, it reflected your parabola. Okay, so let's go to table and see what our numbers are. All right, so y2 is negative. -2 is -0.06. 1 is -1. And if you look at y1 and y2, they're just the opposites, aren't they? Okay, and 2 is, uh-oh, I skipped one somewhere. I skipped 0.25. So I had 0.25 negative, and then I have -1 and -4. So all this did was that it reflected it. It reflected across the x-axis, didn't it? Okay, and we can come over here and graph it, and we've got, let's see here, it's going to be like here, it's on the negative side, sorry, and then it's here, and then we've got -1, -4, and then -16, which is 2, negative 16. And I'm going to draw it. Okay. Same as a quadratic though, it just reflected it. Okay. The last one we're going to look at, I'm going to go back to y2 and change that one instead of changing y1. I'm going to put parentheses, 1 divided by 4 parentheses to the power of x, and I'm going to graph it. Look at that. How do you like them apples? What did it do now?
It's scrolling down.
Okay, so it's decreasing from left to right. We call that decreasing or increasing. This is actually increasing from left to right. This is decreasing from left to right, correct? But what did it do?
Reflected across the y-axis.
Reflected across the y-axis. Look at that. That is a reflection across the y-axis. Very good. So it reflected across the y-axis. And I'm going to go to second in table. And we've got negative 2 and 16. We've got negative 1 and 4. 1, 0, and 1, and 0.25, and then 0.06. So it just reflected across the x-axis. I think it froze too. No, it's still running though. It's just the video thing here that froze. So somebody help Luis out a little bit if you see him in class at some point.
Once you go back and watch the
I don't know. We'll find out. I would imagine it does because the screen is frozen. You know what I mean?
I didn't know if it was just
It's still recording, but I'm guessing that it's frozen because this screen is frozen. What? So please let Luis, somebody have him look at your notes.